Okay, let's take a look at a third and final example, one that's a little more advanced than the first two. And here's the statement. It says a line with slope 3/2 is tangent to a circle with radius 4 and center 3, -5. Find the point of intersection of the line and the circle. There may be more than one solution. All right, so let's take a look and see what we can do on that one. Well, the first thing we notice is that it's the same setting as the last problem in terms of the circle. So I'll draw that up really quick. So 3, -5. 1, 2, 3. 1, 2, 3, 4, 5. So there's the center of the circle. My daughter is here with me as I record, so you might hear some little ones in the background. And the radius is 4, so roughly 4. Looks something like this. And then they say a line with, so I guess the center here is 3, -5. And a line with slope 3/2. Well, 3/2 is going to look, I mean, something like that. I'm trying to sort of up 3 over 2, so it'll have, a slope like that, but it'll be tangent to the circle, so it'll be, one could be right there, so we're looking for that little point there. But of course, another line that has that same slope parallel to it will touch the circle on this side as well, and that's the reason for the mentioning, I guess, in the problem that there is maybe more than one solution. Of course, if we connect this line, the diameter of the circle, it appears that these two lines, if they're tangent to the circle and touching it, then they're going to be meeting the diameter of the circle at a right angle. And of course, that's something we'd probably want to prove, but let's just assume that for now, that we know that is tangent to the circle. So we're after two solutions here. Let's call this x1, y1, and let's call this one x2, y2. And let's see if we can analytically find the locations of those points. Well, one thing we know, of course, is that this guy has slope 3, 2, and so does this one. So if those two both have slope 3, 2, we can kind of think about the slope of this line. And this line, of course, has a negative reciprocal slope to 3, 2. So it must be, well, I guess down 2 and over 3. So negative 2/3 is the slope of the line that passes through the diameter and the 2 points of intersection. And so here's what my strategy is going to be. I'm actually going to try to find the equation of the line that contains the diameter. So the equation of this line, and I'm going to call that, I don't know, line P, I guess. So if I can find the equation to line P, I already know the equation to the circle, then analytically we should be able to solve that system to find the values of x and y that are solutions to both of those equations. So let's go after that. So for line P, we have what? We have 3, -5 as a point. And let's see, negative 2/3 as a slope. So we can try to find out what the equation for that line. To find the equation for the line, let's let x, y be any point on P. Then let's see, from the equation for the slope, which says that slope is equal to, sorry, not x2, but rise over run, which would be y2 minus y1 over x2 minus x1. What do we have? Well, we know the slope. We know what m is. M is negative 2/3. And let's see, we know one of the points, 3, -5, and we could give the other point just a generic value, x comma y. So I'll do it that way. I'll say this is y minus -5, and on the bottom I'll have x minus 3. And so what does that mean? If I multiply both sides by x minus 3, I get -2/3 times x minus 3 is equal to y plus a 5. So let's see, I'll carry the -2/3 through, and what I'll get is -2/3 x. Let's see, negative times negative is positive, so plus 2 is equal to y plus a 5. And then subtracting 5 from both sides, I get -2/3 x minus 3 is equal to y. So in points or slope-intercept form, I guess we'd have -2/3 x minus 3 is the equation of y, where I'll put a little subscript p on this. So that's the equation of the line p that relates the x's and y's that are solutions to that particular line. Okay, we have an equation for the line and an equation for a circle. So we need to solve the system that is a line, y equals -2/3 x minus 3, and a circle. And the circle's equation we found in the last part as x minus 3 squared plus y plus 5 squared equal to 16. So what does it mean to solve a system? It means, well, we're trying to find the values of x and y that satisfy this equation while simultaneously satisfying that equation. And what we hope will happen is that will provide the 2 points that are, I guess, both a solution to the line P and a solution to the circle. Well, how would we solve this? I guess the way I see it is I have it already solved for y up here. Down here I have in terms of x and y, but if I've substituted this value of y in for that value of y, I'd have one equation in x in one unknown, and that should allow us a solution. So let's go about it that way. By substitution, we get, what do we get? Let's see, we get x minus 3 squared plus, oops, not y, now I want to plug in what I know y to be, -2/3 x minus 3 plus a 5 quantity squared, and that's all equal to 16. Let's simplify this up a little bit. X minus 3 squared plus -2/3 x plus 2 squared equal to 16. Okay, let's, since we've got two binomials being squared, let's go ahead and square things out. We'll get x squared minus 6x plus 9 when I square the first binomial. And then the second binomial will be, what, 4/9 x squared. And then I'll have -2/3 times 2, so that'll be -4/3, but it'll be twice. So double the cross product, so it'll be, let's see, 4/3 and 4/3, that should give us 8/3. And it's negative, right? Yeah, -8/3 x, and then plus 4, that all equal to 16. Okay, I see I have two terms with x squared, 9/9 and 4/9, so it'll be 13/9 x squared. The x terms, I have -8/3 and -6, so if I put this over a common denominator 3, it would be 18/3 minus 8/3, so 18 and 8 make -26/3. And then plus 9 plus 4 is 13, but so I'll do that in the next step. 13 equals 16. And I recognize now that I'm getting a quadratic, which is an equation in x squared. Sorry, there's an x there. And that means we could probably use the quadratic formula to solve it. So let's try to set it equal to 0 and use the quadratic formula. So let's see, we get 13/9 x squared minus 26/3 x minus 3 equal to 0. Pretty nasty because we've got fractions, so let's clear the fractions by multiplying through by 9. If I do that, I get 13x squared minus 26 times 3, that's going to be negative 78x, and then 3 times 9, which will be negative 27. Okay, so we have something in terms of 3 coefficients, and of course we have a famous equation, the quadratic formula, that allows us to solve this. If it's been a while since you've solved the quadratic, here's the equation. X is equal to the opposite b plus and minus square root of b squared minus 4ac all over 2a. So a little way to remember that. So let's go ahead and go after that. So x will be equal to the opposite of b, so that's 78 plus or minus square root. Let's see, b squared would be negative 78 squared minus 4 times 13 times negative 27. And that's all over 2 times what a is valued at, which is 13. Okay, so let's do some simplifying. X will be equal to, let's see, 78 over 2 times 13 is 26. And then it's plus or minus. This number on top turns out to be, let me get to my notes here, 7488 over 26. Okay, let's do a little bit more simplification. X here will be equal to, let's see, 78 over 26 is just 3. Plus or minus, let's see, 7488. Let's do a little bit of work on that. If I take 7488 and I divide it by 16, it's definitely has a 16 in it. I wonder if there's another 16 in it. No. Let's see, divide it by 4. Yeah, if I divide it by 4, I get 117, and I can see 7 plus 1 and 1 is 9, so it definitely has a 9 in it. And then the last factor is 13. Okay, so that means that 748 can be written as the product of these 3 numbers, 3 of which are perfect squares, so it'd be 4 times 2 times 3. 4 times 2 times 3 is 24. So it looks like that's 24 root 13 over 26. So that means x is 3 plus or minus 24 and 26 both share a 2. We can call it 12 root 13 over 13. Well, just one way. If you prefer just leaving it as this way, that's fine too. But we found the 2 x values of the coordinate that we think are located here and here. Let's go ahead and see if we can finish this out. We need to find the y value of the coordinates. So let's see. X sub 1 is going to be equal to, let's let it be, let's think about this. If we're back here, then and 3 is the midpoint, sort of, we must subtract to get back there. So it must be 3 minus 12 root 13 over 13. And then let's see, y sub 1. So how could I find y sub 1? Well, y has got to be on the line P. I know the equation to line P. It's that guy. So if I know x sub 1, I can solve for y sub 1. So y sub 1 should be negative 2/3 x sub 1 minus 3. Okay, so what does that look like? Y sub 1 is going to be equal to negative 2/3 whatever x sub 1 is. Well, x sub 1 is 3 minus 12 root 13 over 13 minus 3. So what does that look like? The 3's will cancel here. We'll get a negative 2. And let's see, 2/3. We'll get, let's see, the 3 and the 12 will cancel. Negative and negative will make a positive. And let's see, we'll get 3 and 12 cancel will yield a 4, so it'll be 2 times 4, or 8, root 13 over 13. Okay, so that means that x1, y1 is this strange number, 3 minus 12 root 13 over 13, comma, negative 2 plus 8 root 13 over 13. All right, so that would be one of the two solutions. Oh, I just realized I made a small mistake here. I failed to bring down the negative 3, right? Because the negative 3 and the negative 2 should make this a negative 5. So there we go. I believe that that looks a little bit better. We'll test it in just a second. But by similar argument, we can say that x2 is going to be, where were we? It'll be the addition here term, so 3 plus where am I at? Here we are. It'll be the addition term here, so 3 plus 12 root 13 over 13. And y2 will be achieved by taking negative 2/3 x2 minus 3. Okay, so negative 2/3, 3 plus root 12 over, 12 root 13 over 13. Minus the 3, don't forget it this time. Okay, so the 3's will cancel here, and we'll get negative 2. The 3's will cancel here. I'll get a 4 minus times positive, so it'll be minus 4 times 2, or 8 root 13 over 13 minus 3. So looks like it'll be a negative 5 minus 8 root 13 over 13. So what does that mean? That means that x2, y2 is equal to this weird number 3 plus 12 root 13 over 13. I shouldn't call it weird, but a complicated number, part rational, part irrational here. So irrational as a whole. Negative 5 minus 8 root 13 all over 13. And now the big test comes, are these really the points on the circle, and how do we know? And that's one of the places where technology can help us a lot, because now we can go to GeoGebra and check it. Let me go ahead. As you can see, I've already checked one. So here's the circle that we started with, and what we're checking is to see if these 2 points indeed are the points that we want. So in the input bar, what I'm going to do is just put in x1, y1, and x2, y2. So it'll be 3 minus 12 times the square root of 13 divided by 13, comma, negative 5 plus 8 times the square root of 13 divided by 13. I'm actually going to copy it because the second one is so similar. Hit and enter, and that looks like the right point. I'm going to type in the next one. The only difference here, of course, is we have a 3 plus a 12 square root and a negative 5 minus an 8 square root. There we go there. And let's just see if the line that connects them is the correct line. I'll put it in y equals mx plus b, and I do see it has a negative 2/3 slope. At least that's what it appears to have. And of course we could do some perpendicular lines here. So one that's perpendicular to that one, and one that's perpendicular to that one. Both of those, if we right click on them and put them in slope intercept form, I think we'll see that they indeed have a slope of 3/2. So we do appear to have found the correct solutions. Okay, that's the end of the video, and I hope that this is giving you some insight into the use of analytic geometry to study shapes on a coordinate plane.
Daddy, can I watch it?
All right, you can in a minute.